Dear friends, in this particular series of electrical substation, I am going to provide you many details regarding types of substations and transformers, uh, voltage regulators and transformer foundations, voltage requirement, ST and LT panel, main receiving substation, distribution, electric distribution in hospital through 11 kV system, uh, substation layout in detail, and fireproof insulation for transformer room. What is the economic voltage for transmission? And such different type of subjects which keep on confusing the engineer when he come to field. So tie up your belts. This is a lengthy series on substation. Dear friends, what is a substation? Basically, the definition of a substation says that it is a part of an electrical generation, transmission, and distribution system where voltage is transferred from high to low or low to high or many other important functions. Electric power may flow through several substations between generating plant and consumer and may be changed in voltage in several steps. Mainly, the substation is defined as the assembly of apparatus used to some characteristic, that is voltage, AC to DC. It may be used for power factor conversion, frequency of electric supply. All are included in definition of substation. Friends, we were discussing substations. Uh, the current slide shows types of substation. Substation can be of different type as classified by two features. First one is according to constructional features. The substation can be of five different types. One is indoor, second is outdoor, and substation can be indoor and outdoor both. The substation can be underground substation. The substation can be pole mounted substation. The substations can be built-in substation, ground or roof mounted. Substation according to service requirement feature can be of six types. First one, transformer substation divided into two different subtypes. One is at the time of transmission, second is at the time of distribution. In case of transmission substation is uh, in step up type, and in case of distribution transformer, distribution substation, it can be down step down type. Third, the substation can be for switching purpose only. Substation can be power factor correction substation. The substation can be frequency changing substation. The another category is converting substation. Next is industrial substation. Industrial substation are mostly beyond 25 kVA. So these are the classification. Friends, before we go for detail of different type of substation being used, actually it is very necessary for anybody of us to consider that any electrical substation fundamentally needs a power source. This source can be alternator or AC generator, and in case of DC, it could be battery type. Second, conductors. The conductors in a electrical distribution system, transmission and distribution system may take several different shapes. It may be overhead wire or overhead wire and wires of different type. It could be in form of cables. Cable can also be underground and overhead pole mounted. Simple bare naked conductors. They may take they may be naked conductors. The next category is bus duct. For load beyond 400 kilowatt, we always go for bus duct to carry the current. The third and most important item is transformers. And as I told you, the transformers can be step up or step down. The next essential item of a electrical transmission distribution circuit is uh, control devices that may take the form of switches, breakers, circuit breakers, MCBs, and molded case circuit breaker, A circuit breakers, or simple isolators for transmission and distribution management. And the fifth item is a load. The load can be in the form of lighting bulb, can be form of motors, it can take any shape of any apparatus. And these apparatus may contain resistances, inductances, and capacitances, and their solid equipments, solid forms. This is load is necessary to utilize the energy. Uh, at the bottom, I have shown all these essential components. We start from a generator and go up to load, and in between, the conductors are coming. Bus conductor, buses, overhead conductor, overhead conductor, overhead conductor. Then third item is power transformer represented by this symbol 3. It will be at several levels from here to here. I have just omitted them elsewhere. So first item is generator. The last item is load. In between, all items are connected through conductors. Conductors may be in the form of buses, and we need several control systems, control devices throughout the circuit. Dear friends, the schematic diagram shown above is a generalized Indian electricity generation, transmission and distribution system. India only, apart from Russia and Canada, having transmission voltage as high as 1100 kV DC and 750 kV AC. Most of the British ruled countries have the same type of system but below 750 kV only. Now let me describe the system. The power is generated from any voltage from 11 kV to 13.6 kV in a generating station power plant, and therefrom it is transferred through transmission tower up to several places. First it is transferred at this 11 kV or 13.6 kV. It is transmitted at 11 kV DC, 750 kc AC, 500 kV AC and 400 kV grid substations. So they are taken over the overhead transmission towers, and from there it is, in case of grid, it is brought to a distribution transmission is trans, transmission substation which downloads from above voltage, any of above voltage to 132 kV near a big city. When it comes to a city, big city like Noida, Delhi, Bombay, Chennai, Bangalore, it is brought down, the voltage level is brought down from 132 to 33 kV for industry, and this system is taken to industries, mostly in India, uh, in Noida, Pune, Bangalore, etc. Then from this substation, which is near a big city, the voltage level is taken down to from 33 kV to 11 kV, and further 11 kV to 433 kV transformer for office or residential complex. So it is recommended, dear friends, that voltage should be carried further for transmission or distribution system at voltage as higher as is possible. But there are certain limitations. The following three-phase voltage levels are optimally suggested in medium voltage distribution in a substation or in a campus. Say if your load is up to 100 kVA, that can be done at 415 through 11 kV by 433 volt transformer may be provided by electricity distribution company. It may be pole mounted, and poles are outside the campus. If your load are between 100 kVA to 1 MVA, it is suggested by electrical company that 11 kV is sufficient, and substation is provided by the owner, can be provided by owner. From 1 to 3 MVA, once again 11 kV substation to be or may be provided by owner. Beyond 3 to 5 MVA, you have to go at 33 kV. So you have to mount a 33 kV by 433 volts direct, or 33 kV to 11 kV and then 11 kV to 433. Beyond load requirement of 5 MVA to 10 MVA, 66 kV substations recommended, and substations are mostly provided by the electric supply company as it is in Delhi. If the load is more than 10 MVA to 45 MVA, then 132 kV substation may become necessary. And this is uh, to be provided by the supply company. Dear friends, we are discussing a very important substation layout. The substation of 33 down to 433 or 33 to 11 kV or 11 kV to 433. They have a layout similar to whatever shown here. Now this is a substation containing generating set and oil for the petrol oil and lubricant store, local diesel oil or petrol storage. Now this this particular diagram is for 11 kV to 433 voltage and generating set of 433 and below. In this system, there are several characteristic features. First one is this supplier's ST metering panel is provided in a room which is locked by supply company for their purpose. But they may permit for government concern if the substation is being constructed in a substation government campus, then you may not require this directly, because if it is a government to government, central government to central government, then they believe and metering, separate metering may not be logged. So the electric supply comes through, it may be through overhead line coming like this, or we may have, if the demand is low, then we up to 630 kVA, we may have pole mounted system getting overhead supply from other substation, and from this pole mounted substation, pole mounted, double pole mounted transformer, we bring voltage in. Then next important is ST panel. The ST panel, if it is 11 kV, it is approximately 2 meter wide, and length may be depending upon number of transformer to be provided. In this case, there are two transformers, one here. So we'll have three panel, uh, one for incoming, and second for to the first transformer, and third for the third transformer. The supply is taken like this. Now you have to leave at least 1 meter space behind this ST panel and 2 meter space, working space for personnel to this one. From here we come to transformer room. If there are two transformer room, uh, the ST panel will be three sections and each section of approximately 0.8 meter wide. So this entire length will be 2.4. Now we come to transformer room. Transformer room for transformers 11 kV and above has to be separately provided for each transformer if they are inside. This complete room is insulated by fire brick and the transformer stands on a transformer foundation. Uh, these are the rails over which the transformer mounted. And there may be another transformer similar to it. In, in cases of all this heavy electrical equipment, ramp must be provided. RAM in substations, RAM for the diesel store, RAM for the ST panel, and RAM for the meter room. And another ramp is provided for generator cum LT panel room. And with each substation you have to provide uh, facility of toilet facility and WCs for the staff here, and staff may be sitting somewhere here, this area. So these are the transformer, and transformer primary side is brought like this, and secondary side is taken and joined with the LT panel. This LT panel is having supply through AMF panel, it is here, and this AMF panel is getting supply from either diesel generating set or from transformer. So LT panel, we call it a LT panel, otherwise they are MV panel. MV panels are panels up to 430 volts or similar, and they may be interconnected by a cable trench. Nowadays it is done through bus ducting or above bus ducting, and they get power supply. So this is all ramps, entry through ramps are provided with rolling shutter, and rolling shutter in case of transformers and ST panel should have ventilation facility. Friends, through this drawing, which is actually of All India Institute of Medical Sciences, Raipur. This project was with me as an employee of Hospitec Management Consultant Private Limited, which is the highest company doing with medical healthcare systems. I was their chief consultant engineer. As a consultant engineer, we got two projects out of six M's during 2007 and similar period. Uh, our company got two M's, that is M's Raipur and M's Patna. And M's Raipur I am describing here. Here I utilize a new concept that is not so far done, that means up to year 2007, that concept was not utilized in any of the hospitals. The concept is that if you distribute all the buildings through LT cables, low voltage, medium voltage cables, that means the cable running on 433 volt system, and if your campus is more than a kilometer or even lesser than that, uh, uh, the distribution losses are too much. They go up to 10% of entire energy energy being consumed. So I utilize a concept in which you are getting 33 kV supply because the load was around 10 MVA, and we got 33 kV electric supply from electricity board and converted it into 11 kV. And it was at this 11 kV level we installed 11 kV generating set also, and out of these two, either supply from transformer or supply from generating set, only one supply cable going to different substations. We established so many substations in the campus. Uh, the substation number 2, 3, 4, 5, and 6. So we took 11 kV distribution rather than LT distribution, and I brought this nearest to utility center. This utility center was having AC AC system, and it was biggest load, and so we brought the cable up to this AC station, and from here it is looped to two transformers provided in the medical system, healthcare system. So this was a building here, and from this healthcare system, second transformer, we took it to medical college. This is medical college, and this is the auditorium for this. And from this medical college, we took the electric supply to residential campus, and from residential campus, it is looped back to the main receiving station. The substation 1 is main receiving station at 33 kV, of which half was in open air and half was inside the substation. That means the 33 kV portion was outside and remaining was inside 11 kV, and from 11 kV we went in the utility center. This is utility center here. This was a new concept where all utilities were provided here, and medical college, medical hospital here, medical college system here, the hostels for students here, and hostel for hospital staff here, residences and hostels. Then there is a play station. So the entire complex was supplied through 11 kV, and here at this level, substation level, it is converted from 11 to 433 and taken vertically up here also, here also, and here also. The medical hospital was served through a highway coming from Raipur, and there was a bus station here, and from bus station people could walk to walk through road to hospital. The hospital entry was like this. And the other staff could walk to utility center here. This utility center was having AC plant room, mortuary, and several other such gas systems they were provided. Friends, study this diagram, which is for a 33 to 11 kV conversion substation layout, of which 33 portion was outside from here to here. Now the main components are here: transformer from 33, it is getting 33 kV supply, and through these are the gantry systems: gantry 1, 2, 3, 4, 5, and this is the transmission tower for secondary side of the transformer. From here it may be going to uh, indoor substation, which is 11 kV. Now the various components are clearly shown here. One is the primary 33 kV lines. Second is the ground wire carrying, that we say earth wire. Third are the set of overlines, although these are three overlines, three overhead conductor, they are shown by one line. Then fourth is the transformer for measurement of electric voltage. This is so-called voltage transformer. Then fifth is disconnection switch to isolate the 33 kV side from 11. Sixth is the circuit. This is the circuit breaker, this is the circuit breaker. Similarly here and here. Seventh shows the current transformer. We need current transformer for measurement purpose. Here also, so many current transformers. Then eighth shows you lightning arrestor. This one. This provides lightning arrestor system for, in case of discharge of electricity, they take care of the system. Now, this is the primary side up to here, and this is the secondary side. So in the secondary side, we have once again transformer, current transformer for measurement, lightning arrestor, and ninth is the main, this one. This is the main transformer. This is 33 kV side. This is 11 kV side, and likewise it goes. 10th is the control building, that is substation, control substation, and 11th shows the vertical fence on both the sides. Here, this is the fencing. This is campus fencing. The entire campus is like this, from here to here. Then 12th shows the secondary power line, that may be 11 kV going into indoor substation. So kindly try to grasp the system, see this many times, then it will come to your mind. Friends, this is the isometric view of the same substation which I described in the previous slide, and it is a layout of 33 by 11 kV outdoor substation. This is the outdoor portion, and from here it is going to this. We are getting 33 kV power supply and these are the incoming line, sub-transmission line, and the lightning arresters are provided here. Three, then air brake switches, which will break off circuit. Air brake switches are operated off circuit, so there is no sparking. Then here is the 33 kV step down transformer. This one. This is 33 kV. And why yellow? I have shown the route of voltage transmission. In between we have several gantries. These are the gantry system. Here, vertical gantries. And this is the outgoing distribution line. It may go to indoor substation after this. Friends, in previous diagrams, I have mentioned about pole mounted, outdoor pole mounted, double pole mounted substation. So this is the double pole system, one pole and second pole, and these are their foundations. And here you can see this is the end view, this is the end view, and this is the elevational view. And it shows you different component, the air switch, air brake switch here, then lightning arrestor mounted here. Then this carries fuse system, 11 kV fuse. Then we have the main transformer. Now this pole mounted transformer can be at the most 1000 kVA, but normally they utilize 630 and below. Then this pole structure is provided with the Danger board and LT circuit breaker. These are supposed to work in, through a handle. Supposed to work. This handle is here. So it is supposed to work offload. Air brake switches are supposed to work. Otherwise, you have to operate operate it another way through circuit breaker. अनुराग का चालू हो गया तो मैं डिस्टर्ब. Friends, now we are learning how the electricity is utilized right from main receiving station at 33 kV and up to the last point, that may be fan point, power plug point, or maybe light point. So I have described entire system, and you can see the color coding also, how the system is interconnected. The red line shows 11 kV underground cable. The green shows LT cable 3 phase. This one. This is green. Green. Then the black one shows you point R circuit wiring. We receive electricity at 33 kV at main receiving station, and this main receiving station may be partly outside, and its 11 kV substation portion may be in a building, inside a building. Now, in a large campus, there may be a requirement of several substations, which I have shown here. Substation 1, 2, substation 3 and substation so on up to substation number n. Now I will describe the 11 kV system, and from main receiving station through aisle circuit breaker we come up to substation, any substation inside the campus. I have described in detail one substation, which is this. This substation has a ST panel and metering system, and this ST panel is connected to two transformers. Normally, we always utilize two transformers in parallel, and this transformer 1 is connected to LT panel 1 and another is connected to LT panel 2. From LT panel through three-phase cable, this color, this color, the we are connecting to several main switchboards. They may be in one floor or maybe in several floors. Now, when we come to main switchboard, then main switchboard fix a number of TP and DV. TP and DV may be several on one floor and they may be provided in several other floors. Now, take up a case of one TP and DV. From this TP and DV is triple pole neutral distribution board. Now, this may be 4-way, 6-way, 8-way, 12-way, like that. And each way will get connected to, say, suppose if it is a four-way TP and DV, you can take 12 circuits like this. This is one circuit. You can connect it to as many circuits as the number of ways are available. 4-way will give you 12 circuits, 6-way will give 18, 8-way will give 24, and 12-way will give 36 circuits. 36. The concept of circuit is that once on one circuit you can connect. This is one circuit from here to here. This circuit is on 230 volts, single phase, and we have connected so many points. In one circuit you can collect a point of 800 watt each. Normally it is taken as 1 kilowatt, that means 1000 watt, but we can go up to 800 watt in one circuit. And here the wiring is 2 into 1.5 square mm. And in one circuit you may include 5 ampere power plug, a light, this one, you can connect fan, another 5 ampere, this one. And remember, if it is 15 ampere socket outlet, that means power plug, then it is counted as one circuit itself. At the most you can share two 15 ampere in one circuit. That normally we do. So this is the total distribution system from point wiring, circuit wiring, then TP and DVs, main switchboards, TP and DV connected to main switchboard. Main switchboards are connected to panel, LT panel, that is normally known as MV panel as per Indian rules. Then LT panel is connected, takes power from a transformer, and the transformer gets connected to ST panel, and from ST panel the electric supply comes from main receiving station. So this is in nutshell one system, and this is my copyright, remember. Friends, in this particular diagram, on the top I have shown a LT panel, and by the side of LT panel I have shown a ST panel. Now I will describe the component of this one. The LT panel or MV panel is working on 440 volt busbar system. The busbar are provided here, and from this busbar connection is taken through these switches. There may be several switches connected to some busbar. Busbar is running here three phase, so there will be four busbar and one earth busbar also, and these are connected to several switches. Now these switches may be a single MCV, MCCV, or even air circuit breaker. These are the air circuit breakers here. So I'll describe what is air circuit breaker. Air circuit breaker looks like the item shown below. Now if you are using MCV, each MCV can go up to 1 kilowatt. When you come to MCCV, MCCV are deployed for feeding load of load up to 40 kilowatt, and beyond MCCV are deployed, and MCCVs can go up to 400 kilowatt or 630 ampere. To convert from kilowatt to ampere rating, you have to multiply roughly by 1.6. So remember, one MCV can take up 1 kilowatt, one, and these MCVs are available up to 63 ampere or 40 kilowatt. The next category is of MCCV. MCCV supply you power up to 400 kilowatt, and beyond MCCV we have to go for ACV, and ACV like this deals with the power up to 2000 kilowatt, and they are normally in this simple LT panel. they they are here, so two incoming circuits are there and they are connected. uh, in case of 11 kV we use ST panel, and ST panel comes in units like this. This is one VCV in contrast to ACV. Here in 11 kV it is called VCV, and this is one panel, and they can get connected several in one bus, and then that is called ST panel. The ST panel uses switch as VCV, vacuum circuit breaker. This is vacuum circuit breaker. So like switches here on LT side, on ST side they are vacuum circuit breakers. Friends, this particular schematic diagram shows you different components of a power circuit. We can start. This one is 5 ampere switch, and this switch is known as piano type, and this piano type switch may get combined with a piano type socket outlet, and this socket outlet is having 5 pins. So these are the phase, this is the phase, and this is neutral. And in between, for a smaller size, this is the phase, this is another phase. So phase and neutral, and this earth wire. The the switch, piano type switch for bells can be can have sign of bell over that, just to differ from this one. It is provided with this bell sign. Now, as compared to this 5 ampere, the 15 ampere piano type switch may be slightly bigger, and it is one unit complete. Say in previous year we had been using ironclad three-phase switches, and now these are almost obsolete except in some system. You may find it some old systems. Now these were of two different category. This one is switch fuse unit, and this one is fuse switch. It is known as fuse switch because fuses, these are the fuses, HRC fuses, and they are provided on the switch handle. This is the switch handle, and the cover gets detached like this. It is hanging, not detaching. So these are the HRC fuses, and these are the contacts where these contact 1, 2, 3, they will sit here. A 1, 2, 3 when the switch is closed. And earlier we were using the fuses in like this, porcelain vase rewirable type of fuses. Now here also fuses are deployed. What fuses on slight short circuit gets fused, and then you have to replace them. That is a costly affair. So we have turned on MCVs. MCV means miniature circuit breakers. A circuit breaker by definition is a switch which gets off or disconnected, which makes circuit disconnected when there is a short circuit or overload. Overload is defined as any load more than in excess of 25%. So if the load goes 125, this will trip. But in case of short circuit, once again it will get tripped. The only uh, care taken is that you can break the circuit, but you cannot make the circuit. For making a circuit automatically, you have to employ some different scheme. So now the MCV can be single phase, MCV may be three phase, or it may be a combined single pole and neutral SPN type of MCV, and it could be triple pole and neutral, combined triple pole and neutral type switch. These two different switch, SPN and TPN, are used in the incoming circuit when electric supply comes from somewhere else and it gets connected to your panel. It is the first point is always through triple pole and neutral as per electricity rules. Now this compartment I have shown different type of MCCVs. Now these MCVs can take up to 40 kilowatt or 63 ampere either on single or three phase. From 40 we are jumping to 400 kilowatt through miniature case molded case circuit breakers. These are molded case circuit breakers of different ratings. They can deal up to 400 kilowatt or 630 amperes. Friends, through this table I have described the floor loading details that are required by structural and civil engineer at design stage itself. Now, different type of uh, equipment, electrical equipment require different type of load details on the floor. When they are put on a floor or a foundation, they pose a load of this much capacity. Say in case of transformer rooms up to 33 kV, the transformer puts a load of 3000 kg per square meter. So the foundation has to be designed accordingly. Similarly, generating set plant room up to 248 kilowatt puts a load of 3000 kg per square meter. Lift machine room floor 500 kg, air conditioning system 3000, and remaining items are beyond my scope. But you can refer them for the other components. Friends, this table which I have taken from National Building Code describes the space requirement in case of higher voltage systems. So this is capacity in MVA, one of 3 MVA, two of 3 MVA circuit, one of 5 MVA circuit, two of 5 ampere, and so on. And this gives second column gives you the voltage rating. And friends, as I told you earlier, the outdoor, yeah, the substation is divided in two different portions. One portion is outdoor yard area, and second one is built-in area having 11 kV outgoing oil circuit breaker, oil switch fuse units, and LT panels, etc. So this is the space requirement given in National Building Code. Friends, this particular table provides you requirement of space for 11 kV indoor substation. The first column tells you kVA capacity of transformer 2 into 250 kVA, two transformers, and transformer room will require this much square meter area. The, th the third is these are the outside space, and this total covered space required for the substation area is given here, and before this equipment you have to have a space face width as given in this table. Friends, in the substation construction takes its own time. So in case you don't have any time for constructing a new substation, compact substation may be deployed. The compact substation uh, are readily available, and they are simply to be lifted from manufacturer's place and brought to the site and installed. Of course, they will require a foundation depending upon if they are on ground, or they may be on over the roof also. In both the cases, a foundation, minimum foundation here, the foundation will be below this. That foundation is required for so that um, the transformer, the substation remains slightly above the flood level of that particular area. They can be installed on roof also. These are known as compact substation. The compact substation has three compartments. One is transformer compartment, and another is LT or LV portion compartment, and the ST portion. So these three, and this is enclosed in a metallic structure. This is a diagram of real roof type, top type substation, compact substation. It looks like this. This also a real diagram of rooftop substation system of some site. The rooftop compact substation is placed over a foundation, and these are the earthing items. The earthing is a must in any substation. Friends, this isometric view of a transformer provides some detail about oil fill type of transformers. The oil fill type of transformers, um, this is the main transformer, and these are the 11 kV or 33 kV bushings through which the electricity comes in, and it gets out through another on from other side. Now the entire system, when the power is on, the windings provided in the transformer, these are the windings. The windings are inside this, and these windings I'll show you next slide, are getting warm through the oil circulated therein, and that oil is sent outside for cooling purpose. These are cooling through radiators. So these are three radiators. The winding here will be in three phases, 1, 2, and 3, and each phase is cooled through a radiator in which the oil gets circulated. The oil level is maintained, must be maintained in transformer, and that is through oil conservator. Some oil conservator is provided here, and that keeps on supplying oil in case there is a leakage. Friends, this figure shows you the opened out detail of a oil fill transformer. Each transformer three phase type will have three cores, and this is the magnetic circuit. Uh, a special type of uh, iron is required for that, and each core of this is provided with two windings. This one winding, and this is second. This is the high voltage side, and this is low voltage side. The similarly in other phases, the core is common here. This like this. One limb here, another limb here, and third limb here. and we take out the power through these bushings, and we take out LT through another connections. So this is a complete opened out detail of a transformer. This is the body of the transformer provided with the radiations for removing, provided with the fins for removing heat in the transformer winding area itself. Friends, this figure shows you one 10 MVA capacity 33 by 11 kV transformer outdoor type. So this is provided in outdoor yard. There may be several transformers in parallel. Now, I will let you know when I was having training in BHL Bhopal as a part of my MTech, I myself has designed a 20 MVA 33 by 11 kV transformer of aluminum winding type. That was rare in those days, and we have learned the design of transformers in BHL, which is now known as HAL Bhopal. Now you can see here clearly the transformer has got radiators, the main transformer body having windings, and this is the oil conservator which keeps on supplying oil to the entire radiation system. Whenever any oil leaks through any part of this one, the transformer, the oil conservator provides the leakage oil. Here you have a built-in substation, and the uh, the higher tension side we have got a bushing, and through this bushing the load is taken out. Friends, this is a sketch of transformer foundation. Transformers wherever provided in a building, either in basement or ground floor, they are provided with special type of foundation so that the vibrations are not transferred to the building. Now this is the base plate of the transformer, and this is base plate is grouted in a RCC foundation bed, and dimensions are given here. This foundation is kept away from the structural element through linings. Now you can see this area is filled up with sand cushioning. So this provides a spring type of, when the load comes over this sand area, this is sand filling about 20 centimeter in width all around. Then we provide foam. The sand area is surrounded by foam, and after that there is a air gap, and then finally brick lining 10 centimeter wide. Now this is waterproofing layer, and this foundation is provided floor level, finished floor level. The foundation has to be 25 centimeter above. should start this one. This is a floating foundation for diesel generating set about 20 kilowatt or 25 kVA. So this is not transformer, sorry. This is for diesel generating set. Some substation may be provided with three-phase standalone voltage regulator. The voltage regulator is a appliances which keeps uh, voltage to a required level. In some area, you may get standard voltage less than required one, and in that case, the voltage regulators are provided, and they may have a rotating wheel for keeping the voltage level. Friends, in some cases, the transformer itself is provided with built-in voltage regulator. Let me intimate you that when I was in charge of Safdarjung Hospital as executive engineer, I provided this system for their total air conditioning load through transformer with built-in voltage regulator. This was the requirement. Friends, this is the schematic diagram for a transformer system which shows two views. One is front view and second is side. Both are in elevation. We'll describe the several part of the transformer. But let me tell you, this is 11 kV bushing and this is the LT cable, LT side cable, this one. These are the radiators and they are shown here. One, two, these radiators. This is the oil conservator and oil conservator is provided with a silica gel breather. This is silica gel breather. This breather has a silica gel provided with a color coding. When it is blue, it is alright, but when it gets brown or reddish, then oil, the transformer oil is corrupted, and you have to change the transformer oil. You have to get it filtered. This is the drain provided for filtration purpose. So this legend shows different. This one, the most important is Buchholz relay. This item number 3. Buchholz relay is provided to sense if the oil is to get oil has got sufficient vapor to explode. So the Buchholz relay disconnects when there is a very large amount of vapors produced in the radiators. So this is a safety device, Buchholz relay. And the other parts of transformers are roller. These rollers and transformer are provided on a skid. So you can go through this diagram for learning all part of transformer. Friends, this diagram shows the transformer oil drain. A drain has to be provided if the transformer contains more than 2000 liters of transformer oil. So the leakage oil has to be drained off, and after draining, it goes into a soak pit, uh, and the soak pit is having sand and stone ballast for soaking the oil. This is permanent feature, and this is the vent pipe, and a ramp is provided. So these are the transformer skids. Transformer rests over this, and this is the transformer room, and room is provided with a complete insulation tiles for fire spread. अभी तो तुम्हारा समोसा ही पचा नहीं है, समोसा नहीं पचा अभी। और अनुराग, 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 मैं इस पे YouTube पे डाल रहा हूँ, जरा देख ले प्रोसेस। इधर बैठ जा, एक कोई कुर्सी नहीं है, चलो यहीं बैठ के देख। देखो ये तो पावर पॉइंट प्रेजेंटेशन है, हाँ? पावर पॉइंट लगा रखा है और इसका ये आखिरी स्लाइड पे मैं आया। हाँ, अब इस स्लाइड में मैं इसको क्लिक करूंगा और बोलूंगा, मेरी आवाज़ जाएगी।